Hello. Hi guys, good morning. Welcome back to a new video. In this, again, a lots of thank you for giving love in the last video. The last fourth video of last contest. Now, in this we says double number a number which is represented as a linked list. Now, what they are saying that you are just simply given a number as a linked list. As you can see, I can just simply see this as a 189. I have to double it, which means multiply this number by 2. Now, how we used to do a basic multiplication, I'll do the exact same stuff. Okay, you take the first number 9, multiply by 2, I got a 18. But 18, I can only put a 8 here. 1 will carry over, 8 to a 16. 16 plus 1, I'll get a 17. Again, I can only put a 1, 1 will carry over. Okay, 2 ones are 2. I'll add a 1, I'll get a 3. So this is the reason I get a 378. So the answer for this will be a 378. Same way, let's say this. I have a 999. I multiply this by 2. I'll get a 18, 8, 1 carry over. Again 18, I'll get a 19 now. Because of 18 plus 1, because it's carry over. Again 92, 18, but then 19, but then 1 more carry over, but I cannot do anything carry over here. So 1 extra will be added. Now, these two examples are more than enough to let you know what is happening. So you can easily see what is happening. You have a number 189, but you are applying this kind of manual multiplication by 2 from last. And I know in a linked list, I can only iterate from the starting. So there is one thing for sure, that I cannot traverse or I cannot even find my answer from starting. That is one obvious thing. I am actually iterating from the end to find my actual answer. Thus, I should make sure, okay, I will reverse this linked list. I will make it as 9, 8 and 1. Then I will apply the same operation, as I can now iterate from the left of the linked list. I will multiply this by 2. I'll get a 18. I will only keep this portion 8. How to get this portion? Again, whatsoever value you have got after multiplication, just mod it by 10. So you will get the remainder, which is 8. So, okay, I will keep 8 and the carry will go on to the next value. Here, I will do a carry. I can maintain a carry. That's completely fine. Now, again, multiply my 8 by 2. Multiply 8 by 2. You get a 16. But you also have a carry value now. So, add that carry value. Okay. Now, 16 plus 1 carry is 17. Now, okay, again mod by 2. You will get a 7 here. Okay. Now, again, 17. 1 will carry over. Okay. 1. Then, again, 2 into 1, it's 2 plus you have a carry. Okay, add a 3. But as you can see in this case, when I would be multiplying 999, so let's say this is the list 9, 9 and 9. In the last, it could have happened that when I will multiply by 2, as you can see, I get a 18. Then I had a carry previously, I get a 19. So 9 will come here, but then I know that I will also be having a 1. So although I can just put these values of 8 here itself, 7 here itself, as in like I can just put these values inside this linked list value itself, which means I can replace it by 8, I can replace it by 7, I can replace it by 3. And then as an answer, I have to reverse the linked list again, because the answer is 378. I have to reverse the linked list again and then give as an answer. But for this case, as you can see, if you go on and plan to replace your values, you have a 9, 9, 9. Again, this is post reversing. So you will get a 8 here, you will get a 9 here, you will get a 9 here, but then a 1 also is added. So you have to add an extra node if you have a remaining carry in the end. Extra node, and that's a 1. Okay, and then ultimately reverse it and return as an answer. So you realize there are 3 steps. Firstly, reverse the linked list, then multiply by 2 and maintain the carry at every step, and then utilize that carry. And then ultimately when you have got the result, again reverse the result and get the final answer. So it is 3O of, again it is 3O of n, right? Because your time will be O of 3n. Again, it's O of n it's still. And also in the last video, I showed you that again, this reversing, we performed it iterative to utilize and not use the space. If you have not watched it, go and watch this video in which I've showed you reversing a linked list. We have 2 techniques, either by simply iteration or by recursion. Recursion will incur a O of n space, while iteration will not incur any space. So because of using this technique of reversing a linked list, and again the code also is here, you will get a time of O of 3n and space of O of 1. It is exact same as what we have seen in this video. In this video, we also discussed there are two more approaches when we have to handle the reverse of the linked list, which means either by vector or stack. You can also watch this. These can also come as an approach 2 or approach 3 for you, because again, this is the approach, but it is not a good approach. Why? It will incur a space of O of n. So this will be a O of 3n, but this 2 will give you a time of O of 3n and space of O of n. You can also, by using a vector or stack, you can also utilize and make it as O of 2n, but still more or less the space you have increased. Okay, now you have O of 1 space. I am asking you to improvise it, which means that okay, time is still technically O of n, but for me time is still O of 3n and not O of n. By using this reversing technique, reverse, multiply by 2 and then again reverse, so it's O of 3n. I'm asking you to improvise the time complexity. Space still should remain same, which means now you have to think of, okay, Aryan, I have to think of something else. Now for the something else, I know I cannot reverse a linked list, because okay, maybe I can reverse, but I have to reverse it just once. But reversing once will take O of n time, and if something is reversed, then he has to be reversed back also. So again he will take O of n time. If I will take O of n time and reverse it itself, then iteration also needs to happen on the list, so it will again take O of n time. So if I even plan of thinking of reversing the linked list, I will for sure have to take O of 3n time, and that's what I don't want. I want to improvise the time, which means I have to skip reversing the linked list. Let's focus on a prime thing, which will help you find the answer. Again, that's a very important thing, that why you can even think of that next approach will work. That is that you have to double the linked list. I'm not saying triple it, I'm not saying multiply by 4, I'm not saying multiply by 8. Although this technique will work for everything. This technique of reversing linked list will work for everything. 6, 8, 10, 20. You can multiply by any number. Again, like not if you multiply by 20, make sure like it will become a like big one. Well, like you can say multiply by 0 to 9, any number. But now I'm saying I'm multiplying just by 2. Let's see how a multiply by 2 actually looks like. So what was happening? If let's say I know I cannot reverse it, which means I have to iterate from the starting itself. And iterate as in I know that I ultimately have to multiply by 2. If ultimately I have to multiply by 2, what will happen? Okay, in worst case or in best case, I should say 2 will multiply by 2 and I'll get a 2 here, right? Okay, obviously, but there is a again, okay, that's obvious, but Aryan, if you remembered, answer was a 3. If I just put the answer was a 378. Answer was a 378, but you got a 2 answer. It's wrong. Yeah, I know it's wrong. Let's see. Okay, let's see that you multiply this 8 by 2. Okay, then you get a 16. You know that only 6 can come here. Although it's also wrong, but yeah, you know only 6 can come here. One has to carry over. Carry over where? Carry over to the previous node. You are iterating from left to right. So this is the previous node. So this is currently the previous node. This is currently the current node. So the 1 has to add on to the previous node. So I will go on to the previous node and add a 1. I will make it a 3. And if you remembered, I specifically mentioned, but Aryan, what if, again, right now you just did a carryover and you just added the number onto just a previous node. What if he has to go and add something to the previous also? Which means I am saying that if I add something here, what if he becomes more than 10? Because if I have an 8 number, if I add 10, if I have an 8, if I add a 6, so he will become 14. So for sure, he can also result in carry over in the previous. So Aryan, are you saying you will maintain all the previous numbers in the past? No. Why? That's the beauty, that the number is 2. So if the number is 2, and I know that all these input numbers, if you have remembered, all these input numbers are from 0 to 9, right? So all these numbers are actually single digit numbers. So if max to max, in worst case, if I say that could have been 9 could have resulted in a number called as 18. Still, I would have only put as 8. and I know that my numbers are 0 to 9. If I multiply by 2, I will get a 0 to 18. Max to max carry over value can also be 1. Max to max remainder can be a 8. Max to max after doubling up. This is the original number. After doubling up, max to max carry can be 1. After doubling up, max to max remainder can be 8. So if the max to max number is 8, even if again max to max carry can also be 1. So max number, max carry, even if I add them, I get a 9 max to max. It will never exceed beyond 9, and that's the beauty of doubling up. And that's the reason I told you this we are applying, because it is easy to double up and we don't have to go back onto all the previous nodes. Now let's continue further. What happened? So we took the track of the previous node, current node. Again, this was very important to know that why this technique will work only for doubling up the numbers. Now, okay, we have the current node. We just got here. We had 2, but then we realized that on the previous node, he will get a carry because of the current node. I just maintain 2 nodes, previous current, like this I will maintain. Okay, previous will get a carry because of the current node, and I will add a 1 in this previous value. Okay, then again I will shift both my previous and current. Now my previous comes here, and now my current comes here. 9 into 2, 18. I will have a 8 here, and the carry over will go to the previous node, which is previous node here. I will simply add a 1 here, he'll get a 7. So this is the new value. Let's see with the next example also quickly. That okay, we will have in the very beginning, my current will be here, my previous will be null. Oh, this can be an edge case. That okay, if your current is here, okay, my current is right now here, I will simply multiply by 2. I will get a 18. But right now I don't have any previous pointer. So for sure, if there's no previous, which means this was the head node. This was the head node. If it's a head node, I have to make, and again, I got a carry of 1. I have to make a new node for that carry. So I'll make a new node for that carry and assign it to the current node. Again, I'm just replacing this 8 with the current node. So I made a new node. This is the new node. And I said that new nodes, this is the new node. So I said new nodes next is the current node, or I can also say new nodes next is the head. And also make sure to assign head to this, because this is your new head. Cool. Now again, 9 into 2, 18. Again, 8 will come here. 1 will carry over. Again, let's shift both the pointers. Previous will come here. Current will come here. Right? Okay. 9 into 2. 9 into 2. It's 18. 8 will come here. 1 will carry over. 1 will carry over to the previous node. So previous node will carry over and will put here. Okay. He will change and add a 1. Great. Now again shift both the previous and current. So previous will be here, current will be here. Again 9 into 2 multiply 18. 8 will be here. 1 carry over to the previous node. So I will simply add a 1. I get a 9 here. Again, these are already pointers, like already are pointing. And again, ultimately my current reaches end. I am done. So this is a simple code by using simple 2 pointers. That earlier in the very beginning, this case is not required, because they are saying that you will have 1 element for sure. So nothing is very for you, but still I put in as a case. Current is pointing to head, as I showed in the very beginning also, that if I just show in the very beginning, this is my current and this is my previous, which is pointing to null in the beginning. So current is head and previous is null in the beginning. While my current is not equal to null, as you can see, while my current is not equal to null, simply keep on traversing. And if I traverse, firstly, I will have to find a new value. Okay, what is a value after being doubled up? 9 into 2. The value is 18. So it's a value which needs to be here. So in the very beginning, if you remembered, the value should be 9 into 2. This is current node. This is previous node. 9 into 2. It will be 18. So 8 will come here. Ideally, at the current step, it will not increase. It will increase only when my current is here. And then I will ask my previous to increase. So then it should increase. But right now it will be 18. So 8 will be there. So new value is current value into 2, which is 18. If this value is less than 10, then simply update the current value with the new value. As you can see, 1 into 2 was a 2. So simply update this and say it is a 2. If this would have been a higher than 10, so you realize it would have become a 18, which means 1 should be as a carry. But this carry can have 2 possibilities. As you can see, it can have 2 possibilities. What if your previous was not even there, then you make a new node. If the previous is there, then add to them. So, okay, in else case, which means your new value is more than 10, more than equal to 10, then you will get the current value as the modulo. As you can see, I'll only put a 8 here. And then the carry, which will for sure be 1, right? Which will for sure be 1, that I will decide if the previous is null, then I have to make a new node. If the previous is not null, then I will simply add on the previous node. So if the previous is null, then simply make a new node with the value of 1 and then assign the head to this new node, and heads next will be current. As I showed you here, this is the new node, heads, and this is the head itself, and heads next will be the current. Okay, what if it's existing node? If it's existing node, go on to the previous value and add a simply +1. If it's existing, for example, when I was here, my current was here and my previous was here, then I know that my value is 8. Okay, I put it, but I had a carry of 1. I will simply go on to the previous value and add a 1. I get a 9. That's how I simply did it. And ultimately keep on repeating until you have your current as null. And you can also see that you are also shifting both the pointers simultaneously. Now, with this, you will see that your time is actually O of n and space is O of 1, but you are using 2 pointers. If the if the interviewer is still asking you to improvise it, I don't know why he will ask you, but yeah, it can still be done by using a single pointer. How? Simply utilizing the fact that right now I will only use my current pointer. But Aryan, current pointer, I would still need the previous pointer, right? Because with this current pointer, if this will be multiplied by 2 and if it increases, then I was going back to my previous pointer and actually adding a +1 here. That is what I was using my previous pointer for. The same can't I do it with a current pointer? But Aryan, how? I will say that, okay, this is my current pointer. I will go to my currents next and ask him, bro, if maybe I will double you up, will you give me a carryover? If yes, then I will add right now only. Earlier, I was adding my carryover when I was at the current node and I was adding carryover for the previous node. But then right now in this case, I am at the current node. I know I cannot move back. So I will go and ask my next node, bro, is there a possibility that you can give me carryover? He will say, bro, I will multiply by 2 and I will see. And if he will do multiply by 2 and if he gets a carryover, oh, I know, okay, he will give me a carryover. I will initially, in the very beginning itself, I will add. So what is the change which I will do? Simple change, very simple change. You know that you will not be needing this previous pointer. You will still have to iterate on the current pointer. You will still have to find the new value. You will still have to check if the new value is less than 10, just simply get the new value. Okay, just simply update the current value. You will still have to go to this else condition and see that will you, what like right now also, it makes sense that even if I am at this current node, right, I will put a 16 here, 1. So 1 will carry over, 1 would have been carry over to the previous node in the previous step itself. But now I have to only worry about the current node at the current node, and that will have and give this node will actually go to the next node and ask, bro, if I will, it is the current next, it is currents next. It will go and ask, bro, if I double you up, will you give me a carry? So if he will become 9 into 8, like 9 into 2, which is 18. So whatsoever will come here, I will not worry about because that I will make sure. But if he will give me carry or not, I will ask him. If yes, I will add a +1. So what you will see, okay, where it is gone. Yeah, in the existing code, I will still have to know what is the current value, which is new value mod 10. Now, if the previous is null, okay, there is no previous concept here. I should say rather, if my current is equal to head, because there is no previous concept here. So I need to remove this previous node altogether. If the current is head, which means I am at the first node. And if at the first node, if this doubling up, because if it is high, else condition says that the new value is more than 2, like more than 10, more than equal to 10. Then which means that, okay, this will be replaced by current equal to head. I will say, I will have to make a new node in the very beginning. So I'll make a new node in the very beginning and assign the exact same stuff. Now, I know the else portion will not come. Rather, I will again, this is the thing which was done. Again, previous will not assign to this. This is also removed. Rather, I will just add a simple line here that if let's remove this. If my currents next, if it is not equals to null, and currents next value multiplied by 2, if it is more than equal to 10, then I know that the next value can give me a carryover to me, or will give me a carryover to me. Then in that case, I will say current value plus 1. That's it. This is the only change in the existing code which we will do. Let's see the code freshly. So you will see previous is gone. In this case, I have just put current equal to head, exactly same code. In this case, I have put if current next is not equal to null, and if the current next value multiplied by 2 is more than equal to 10, then simply add a plus 1. And by adding a plus 1, I know that this step will only be moving my current pointer. And again, time and space will still be same. It's just that rather than using 2 pointers, now I'm using just a single pointer, and that's the time and space complexity. Cool. Bye bye. Take care. If you liked it, please smash the like button. And if you want to watch the crash course, you can just see the link down below. It's a new channel, and we'll have more great content, more crash course coming in. Bye bye. Take care. Please like it and please share with your friends. That's help a lot.